Good morning, everyone. Welcome to today's weekly webinar here at the Engineering CAD Systems Support Office. Today's session is part 2 of the template design basics. I wanted to review a little bit of what we did during the first session. We covered what's changed versus f.ss2.itl. Kind of went through the folder structures of the new f.ss3.itl. We covered a brief introduction of the template library conversion utility. We talked about the need to create your own project template library, and we're now naming it the same name as the project and storing it in the roadway folder. That way, when you get up into the f.ss3 workspace, it will automatically recognize it. We went over a little bit of the create template dialog, template library organizer, and then I started talking about some of the best practices. And today I'd like to cover what I typically follow as far as development steps on support calls when people call in, and also in our training classes. And then also some common questions that come across when people are designing their templates. So the best practices, I'll just review those real quick. Make sure you create a project template library in the project folder. Use the template library organizer to copy over f.templates when you first get started, rather than trying to start from scratch. It'll help leverage your productivity for sure. Organize your templates by corridor. If you've got multiple corridors on a project, then just create a separate folder for each corridor. For example, you might have a State Road 87, which is your mainline corridor. You could have either a mainline folder, or you could have a State Road 87 folder. And then if you had a crossroad, maybe it's 15th Street and 16th Street, you could have separate folders for those. And then if you're going to model the crossroads, you could keep those templates within those folders. And that's what I mean by organizing templates by corridor. As you build your templates, I typically like to version them. That way, if you go awry in something that you're trying out or something that doesn't work, you can always go back to the template that you had started from. And I usually version them underbar 1, underbar 2, all the way through until I've got my final template, and then I'll have a list of different templates out there. You can also organize them by template drops. For example, stations. If you know you're going to use a template from this station range to this station range, you could actually name it that way, and that would help organize it as well. Using the apply fixes when you're building your templates or not, just be aware that when you are and when you're not using them, there are some components that can be added that need them and some that already have them. So you got to kind of just get used to using that, and that is in the tools options in the template create template dialog. As a rule, we like to see one green point per template. That just assures rigidity when you're applying your template on a baseline with a vertical profile or an existing ground profile. We also talked about removing the point name overrides, at least in the backbone of your template, not necessarily on your end conditions, but it's within the backbone, and that will that will keep from having issues down the line in your corridor design. Same thing with the component name overrides. We're delivering them now without it checked. In previous versions, they were all checked on. So if you have some previous templates that you're going to convert, we're going to try to make sure that we take off those component name overrides and point name overrides. Use the same label on common constraints, and that is for things like pavement depth or pavement slopes. If you're using, multiple templates on your corridor, you would want to have the same label, so that when you go into the design of your corridor, you can just change a label and it changes all the points on your template the same. And then we can talk about creating a good parent-child relationship, organizing in your active template. That just makes it easier for someone to read, and also easier to turn on and off different things when you start adding intelligence to your template. Today I want to talk about the development steps, and I'll kind of go through these. But you're going to start with usually a typical section, and what you want to do is grab a PPM template that's nearest your typical section and then modify your template to meet those conditions. So for example, if I just escape out of this and go back to like this would be a normal typical section on a project. It's usually developed prior to starting the modeling of it, and you can see that I might want to use a typical 4-lane urban section here for this bottom template, where I've got curb and gutter on the inside, curb and gutter on the outside. But you notice that the sidewalk has been changed to where it's up against the back of curb, and in the PPM it actually has a sidewalk utility buffer there, so you would want to modify that. Also in the PPM template, the sidewalk width is 5 feet rather than 6, so you'd want to modify that as well. So all you have to do is go into your template library, and this is basically where we were last week. We copied over the template, and I'll turn off these point names. And this is what I'm saying. We've got, I copied over actually the examples that has the variable medians, and what I really want to do is look at the normal. I'm going to start out with this normal PPM template that's just a static template, and that's found over in the template library organizer. And if you go to the our workspace in the GEOPAK corridors folder, there's an ITL file. In that ITL file, it's organized by different components and things that we went over last week. And in the typical sections PPM, this is where all of our what we called static templates are. And all I did was found this 4-lane divided 45 miles an hour or less. I picked this template and put it over in my ITL file. And so I would start with this. In order to make this look like the PDF file, one of the things I'm going to do is I'm going to modify the sidewalk to be up against the back of the curb. Okay, so you can zoom into it, and this utility strip, I don't want to delete the utility strip because there may be a situation where you want to add a utility strip. Maybe you're going around a radius. There may be some reason, or it may be a change in the future. Something changes in the design, and now they want to put in a utility strip. So the point there is that I wouldn't delete this line. I would just zero out the length of it. And you can do that simply by looking at the point that it's constrained from and then setting the horizontal constraint value to 0. So as soon as I choose 0, I choose apply, and you'll notice that the horizontal feature constraint is checked on here. Now this is, I consider, optional. If you know your project does not have a varying situation, then you just don't necessarily need this checked on, but I'll leave it on. It doesn't hurt anything to have it on, especially in SS3, because unless you add those corridor references, it's not going to use this as an override anyway. And for people new to template design, this is essentially what this really is. It's an override of the horizontal distance or the horizontal constraint that's in a template. And I'll cover that. Probably, hopefully, within this hour, as far as this whole range thing and all that. So I'll just, what I'm trying to do now is just modify this to look like the typical section. And so I'm going to do the same thing on this side, set it to 0, and then choose apply. Now on this back of curb, I kind of have two options. I can either let it use this horizontal feature constraint, which would be the override of the width, and then add in this reference in my design, or I can set it to a hard 6 feet, and then if I uncheck that horizontal feature constraint, it would always be 6 feet. There'd be no override for it. So I'll leave it that way as well. It doesn't hurt anything in this case to have it that way. And of course I did miss this other side. So set this to -6. Apply that and close. Now let's go back and look at this typical section. Also see that I've got a 1 to 2 slope here. It looks like this is needing a variable slope possibly. So what I can do is go over to the DOT template library, and I pulled over in the components folder last week just the parts, I believe, for end conditions. Actually, it's in the end conditions folder. I did parts. So I could add in each of these individually, or I could go over and add in the decision tree, what I call the decision tree or the decision slopes that has them all together. And so I'll go back to the template library organizer and I'll go ahead and get that end conditions decision tree so you'll know what I'm talking about. In the end conditions folder, we now have the cut fill that has no right-of-way constraints on it. We have the one that has the right-of-way constraints on it. We have a end condition component set that has the clear zone point established for it. And then this is just a trigger line. So what I'm going to do is just open this up and go into the end conditions folder. I'm going to grab this whole end conditions folder and put it up here. I'm going to delete the other one, and that way I'll have everything that I need. So now you see I've got an end conditions and end conditions 1. So I'm going to delete this one that just has the parts in it, and then I'll have everything. So that's how easy it is to add things to your templates, or I'm sorry, to your template library. And now I want to go back to the components and find this typical section one that I've been modifying. Whoops, wrong one, this one right here. And I probably should have, before I did that, is copied this and put it over in my corridor templates folder and pasted it there and then renamed it. So in this case, I'm going to rename it. I'm going to call it webinar 1, underbar 1. And then once I make those edits, now what I would do, now that I had sort of modified it this way, I could go ahead and, I mean, I didn't make much edits, but I could copy this and then paste it on itself. And this is what I'm talking about, versioning the template. So when I rename this now, I'm going to call this, instead of underbar 1.1, it's going to be underbar 2. And then I'm going to set this as the active template that I'm editing, and I'll go over and add in these end conditions. So the end condition I'm going to add is this one here, which is, and before I do that, I want to go to Tools, Options. It's like we did last week. I guess it's been a little while now. You can either check this option on or go to the Preferences and load it. And then choose OK. And then make sure you bring your dynamic settings dialog up so you can see what you're editing. And then if you wanted to see whether or not these had affixes on them, you could just double click on that component and look and see that they don't have any affixes. So that's the case where you would want to apply them as you put them in your webinar 2. And then what I would do is just grab this particular one, and I'm going to turn the point names on because I'm going to target it for this this 2-foot level sod point that's outside of the back of my sidewalk. And all I'll do is drag it, and while I'm dragging it, I can right click and mirror, and I'll place it on the end of that point. As long as it connects, it will merge them automatically. And if you don't know whether or not it merged, all you have to do is right click on a point, and if a merge option shows up, then obviously you need to merge the points. If it doesn't, then it merged them automatically. Now last week I mentioned, or the previous session, I mentioned that if you pull over, like in this case, let's say I took this cut fill here, the same one, and I drag it over and I miss that point like that, right? I can still move that onto that point by simply right clicking on it and choosing the move point, and then it will basically snap to that location on that side. But notice that the mirror option doesn't work with the I guess, the template edit move, if you want to think of it that way. So now I would have to right click and move it on this side. Now here's the thing about the move. The move inside of a template editing session does not merge points. Notice how I have a green point here now. Well, that's from the original point. And as a matter of fact, if I double click on this or do a right click edit, it's going to tell me that there's 2 points there. And this is what I'm saying, you would want to merge those points, because now, although the backbone is rigid, the way it was built, if you did a move point on this rigid template, notice how they're not connected. So whenever you do a move inside of a template, you have to merge points. So that's, I merge that point. And the one I want to delete is the tie point, which is what came from my end conditions. So I would do the same thing over here and merge points and delete that point. Now I have basically the end condition slopes that are defined here, where it just tells me that I can have a variable slope here. Can't be flatter than 6:1 or greater than 1:2. Now, the other thing to note about end conditions is they have priorities, okay? If you hover over them, it's going to tell you what the default priority is. See, now that's 32. This is probably 34, 33. And then each of the fill ones has priorities too. So the lower the priority will be the first one that tries to solve. Now, whenever you add anything that's considered an end condition, and so far we haven't really talked about the different types of lines and points that you can put out here, but essentially you have, if you go to do a right click or go to the edit, or add, I'm sorry, if you do the add button, you can add different types of things to a template. And you can add a simple component, a constrained component, unconstrained component, null points, end conditions, and overlay stripping. So if you wanted to add, for example, a simple component, and if I right click and uncheck this mirror, a simple component is just that. There is a default simple component out there that is a -2% slope with a thickness of 0.4 of a foot and a width of 12 feet. And it's going to use whatever the last feature you had set. And notice that whatever feature you choose here, it changes the color of it. And basically that is what's called a simple component. Okay. Now it's supposed to look like a pavement, so it'd be a simple pavement type component. That's one type. I can cancel that by doing a right click. If I want to add a constrained component, what this is going to try to do is basically connect to other points, or it's going to have it's going to build constraints as you draw in here. So I can just click on a location, and then it's rubber banding, as I say, and then click on a different location, and now it's also trying to create a shape. So if I right click, I can either do uncheck the closed shape, and then it's just a line, it's trying to connect another line, or I can make a closed shape out of it and it tries to create a closed shape. And then as I build or add additional points, they're all constrained to one another. So then I would do a right click finish, and now if I look at this, you'll see that this point is constrained at a horizontal and a vertical distance from the previous point. And because I didn't have a point name like seed name, it's labeling them all just right underbar, left underbar, and it adds a 1 to them or appends it to them. If I back up and do this again and say add a constrained component, but before I do that, I come over here and put in a point name, a seed name. I can just call it Vern for now, just for demonstration, and do the add constrained. As I click points now, and because I have apply affixes turned on right here, if I'm right of the center line, it adds in right underbars. If it's left of the center line, it adds in left underbars. And then it just appends a number to each of the seed names. So you can kind of see how that works. And I can do finish and Control Z, undo. Now the next type of component that you have here is an unconstrained component, and that's just that. As you draw them, Notice that all the lines are green, and then I do a finish, and if I edit any one of the points, it's free. The problem with doing that is there's no rigidity to it. So if I apply a control to this and just do a move, you notice that it's free. Nothing else goes with it. Whereas the other one, it has the rigidity built into it. That's what constrained and unconstrained is. The next type is a null point, and a lot of times we'll add in null points, and it's going to use again the same name. And in this case, we want to make sure that every point that we draw in our templates have some type of feature name, because this is very important when we go to the modeling stage. And so we have two different ones. If it's a miscellaneous point that you're not going to use in your model, then you would use a miscellaneous point. Otherwise, you're going to want to pick one of these types of features out here, or point styles. So I'm going to go back to this template null point in this case, and then I can call this, maybe it's a baseline point that you always want to show for some reason on your template. So you can just click there, and then then I'm basically adding affixes to it. If I didn't want that affixes, I could have done the same thing and did a null point here again, and just constrain it there, and now it's essentially just a point out there. And points come in free, but you can always constrain them to other points if you want to. Like if you wanted this baseline to show up 3 feet just for display purposes above your center line point, then I'm going to delete this one, the erroneous one. And then if I want to constrain this one, I can just click on the point, and I can either do it from the edit point dialog by double clicking on it, and then coming out to the constraints and using a horizontal, and then I use what I call this picker button to go pick this other point. Or I could have picked it from the list. If I knew what point I was trying to constrain to, I could pick it that way, and then I can set the value. If I just choose apply, notice how it turned yellow. That's because it has one constraint. And if I put a vertical constraint on there as well from this point, and then I said I was going to set it 3 feet above there, so I can change it to 3, and then choose apply. Now I have a baseline point, null point, that has nothing to do with my template. I'm just going to use it for labeling purposes in the future. Or I want to reference something else off of it, possibly. It could be a milling line or something like that. There's lots of examples. The next type is an end condition, which is what we brought over. And end conditions are a little different in that they target things. So you'll notice that down here, whereas a simple component had a name and a type, this actually has, a feature. This one actually has a target. And you can target lots of different things. You can target a terrain model. You can target an elevation specifically, a horizontal or a vertical alignment, or both. You can also, what we normally do is target horizontal features, but you can also toggle vertical features or both. So if you had a 3D line out there that you wanted to target, you could do that as well. The most common one in this case would be the targeting of a surface. So if I just draw a line out here, and I'm just going to call this an example here, and then I'll go ahead and check apply fixes, and then if I just draw this first point, and I want to pay attention to what I'm actually drawing out here, so I have to make sure that I use the right feature. So if this is a slope line, I'm going to use slope. If it's if it's something else, typically you're going to either be a template miscellaneous or you're going to do a slope. And then so let me just pick slope, and then if I target it here, what I can do is give it the target a distance by just basically constrain it from this other point to find the target. So let's say I do that and then do a finish. So now this line is, if I look at the point properties here, it's actually at a negative 26.64%, 24 feet. Well, that's not a standard slope or standard width. So I could change this to say -1/4, or I could have used an exact key in here with this key in dialog, and I can show you that in a second too. I'm going to set this to 25 feet and choose apply, and now it's going to modify that. Now here's what happens is this is going to try to find its target. The target, if I double click on the line, is, and this should just be an example, a right example slope. And it's going to use the feature definition slope. It has no parent. I want to include this in the triangulation of my whatever I'm building. Now this is important when you're using trigger lines to make sure this is unchecked. And then this is the target. So I'm looking for the terrain model, and I'm using the active terrain model, and its priority is 1. So that's how you build a specific end condition. And then when you choose apply, so what it's going to do, it's going to try to find that target within this distance of 24 feet from this point. If the surface falls somewhere in this distance, then it will solve. A good way to check your end conditions in this case is to go to this test box. This test box will emulate where your targets are, not just where your surface is, but where all your targets might be when it's pushing it along the corridor. So this shows you the backbone of your template, and notice that all of the end conditions are basically, I don't know if you can see that, but they're dashed out. You can barely see them because they haven't solved yet. So that's what this, among other things, that's what this test end conditions dialog does. So now here you see that I've got my available target section. I can widen this out here, and then I can pick this, and now I'm going to draw this as though it was, as though my corridor, I was placing this template along my corridor, and how would it, where would the interactive terrain be? So this white line then draws where the interactive terrain might, where the horizontal and the vertical profile of your template is being placed relative to the terrain, I guess is what you're trying to say. So here's the point. Notice that this, I can zoom in here. Notice that when I'm in this range of that little end condition that I created, that it solves that target. But I'm also getting my other slope lines to solve as well. But when I get outside of the range, it doesn't target it, okay? And that's what that's showing. So that's how you can test your end conditions, okay? Now, you'll notice that if you'll just look at the other slopes on this side over here, you'll see that as I move along, once the horizontal distance exceeds, for each of these slopes, exceeds what it's set to, it's going to switch to the other alternate, okay, or the other slope condition. And how does it know which one to do when? Well, that's based on the priorities when you build it. And so if you close, if you look at any one of these, I'm just going to delete this, by the way. If you want to delete something, you just right click and do a delete components, and you can draw a little line. You draw a little line like that, just dragging your left mouse button. Or if you right click on a component, down at the bottom here, you also have a delete component, what I call delete component singular, where this one is delete components plural, and that way you can draw lines across many things. This one is delete singular, and it is acting on the one that you right clicked on, so I can do it that way as well. So I got rid of that one. And so we're focused on the priorities now of end conditions. And if you look at the actual component properties, it tells you the priority that was established when we drug that over, okay? And if you look at one of the 2-to-1 slopes, you'll see it has a higher priority. So really, you can test that also in your test button. There is a check priorities, and it says there's no end condition priority conflicts found. But do you want to edit them anyway? Sure. And now it finds that I have actually 2 places where I have a decision tree on the left buffer and also on the right buffer. And so that's where priorities would come into play whenever they have a common point. So notice that if you remember, I had 2 end conditions solving the same surface target. That's because you can have multiple end conditions as long as solve, as long as they don't have the same point. And that's why the logic of it worked that way. But in a case where they all come from the same point, then you have to have priorities. So at this point here, I look at the right buffer out, I can choose edit, and it brings up all of the different, and as I move, if I click on each one of them, I can see the priorities that are established for each of them. So it's going to try to solve a 6-to-1 fill first. If it can't, 4-to-1 fill, so on and so forth, to a 2-to-1. And then if it can't do any fills, it goes back and it tries to put in the nearest cut that will work. So that's why when the line was above the point, there were no fill conditions to solve. So it started placing in the cut end conditions. And that's how, basically that's how these end conditions work. Now, you can also have, if you look back at the template, you can also have end conditions. I have a do not construct in this one that are infinite and that are do not construct and have different targets other than the surface. So if I just choose to uncheck this do not construct, what you see is another end condition out here that's looking for a handrail. As a matter of fact, how do I know that? Because if I double click on it, I can look at the end condition properties and find the target type. And it's looking for a horizontal feature definition called a pipe rail, a pipe handrail, or a guide rail. And so if you wanted to test that one, now that I've got it to where I can display it, and notice that the endpoint has a priority, has a end condition is infinite. This overrides whatever the horizontal distance that you placed on there, whatever constraint you placed on there. Now, if it was not infinite, then it's only going to try to look for a pipe rail within these limits for a target, which would be right from the back of curb to 1 foot in front of the curb. But if you have infinite, then you can draw your pipe rail out in your plan view basically anywhere outside of the back of curb, and as long as that's shown, it will basically turn on this part of this template. So I mean that adds some additional. This is a basic what we call trigger line or end condition that turns on other components. So if you do a test now, you'll see that in my normal situation here, I have a normal sidewalk because I don't have a target. I have it drawn in the target for the pipe rail. But if I draw that in here, notice that as soon as I get left of that begin point, it's going to flip on or trigger on the pipe rail and also the sidewalk footer that goes with a pipe rail here, and it draws it in there. And notice it is infinite. If it were only a foot, then this would only solve in a foot situation, and that's the basics of how these things work. Now, how do you get this to turn on whenever a target is met? Well, that's what we call the parent-child relationship. So if you look at this component here, the name of it is handrail test, and it's looking for that target. So all I have to do is then make this handrail a child of the handrail test. And so anything that happens with this one, in other words, if the target finds itself and turns on, then this will turn on just by the parent-child relationship of the two. And then the same thing with this. This one actually has a parent of the handrail. So because of the relationship, since this is a child of this and this is a child of this, if this one solves, they all turn on. And that's essentially how it works. Then, because we don't want to see a little white line out there in our cross sections or in our model, we don't necessarily want to see one, then you could check the do not construct, and it would still solve this situation, but it wouldn't actually draw the line. If you choose apply and close and then go to the test button, you'll see that if I draw this out here, it's not going to display the line even though it's actually creating it, but it's solving it, but it turns on and off that as well. And that's, in its simplest form, that's the intelligence of a trigger line and end conditions. And that is this type of component that you can add. They're all called components, but you know, they're really different types of components. And then the last one is the overlay stripping, and that is essentially that's going to have a sort of a limits. It comes out as a single line, and usually we use the milling or overbuild components. So let me just find the milling in this list. Pavement milling would be this one right here, pavement milling. Nope, that's not it. Pavement milling PX. I'm not sure. Oh, that's the point name. This is where the actual component definition is down here, excuse me. So if I do pavement milling, normally we see that as a light blue. And right click and do a finish. Now what this really has is a sort of an envelope of its top height, or its top limit, and its bottom limit. So in this case, it's follow surface, but if I want to do follow surface, follow component, and then choose apply, and if I go to the test button, now just focus in on this line, basically what it's saying is that this line, the top limit, is going to be wherever the surface is, okay? And the bottom limit is going to be wherever the component is, okay? So when you go to test, it's hard to really kind of understand this, but if you draw in the active terrain, if you think of it like this is where the active surface is, then because of the location of that component, that is the milling depth. Now once I get beyond that, there's not a follow surface for the top or for the bottom option, so it's going to be basically, it's not going to mill anything. But as long as you've got it set up that way, such that a stripping component has a follow surface follow component and it's a milling type, then it basically draws that envelope for you in the model and also in your cross sections. Now if you wanted to change this to a pavement overlay and then switch these and say that the top option actually follows the surface, the top option follows the component and the bottom option follows the surface, then if you were above and choose, did I choose overlay? I meant to use overbuild. Meant to see yellow. And then do the test. Now if you draw the active terrain in here, once you get below this, that would be a situation where you actually have to build up your template in order for it to hit that component. So that's why you basically change it that way. Now we've taken care of all those settings whenever you use our, if you remember last week, we created a resurfacing template and we placed all these in here so that if you do the test now, and I have end condition conflicts here, which I'll resolve in a second, but if I draw in this surface, you'll see that it's going to draw in either milling or overbuild depending upon where I'm at, okay? And it looks like this overbuild on this side might need to be reset a little bit, so that's a good visual for that. And don't expect you to understand these overbuild and milling components at first. I didn't. It just takes a while working with them before you kind of get it in your head how they work. So let me go back to our webinar 2 template, and I'm going to delete out this last component type. So that covers all of the different things that you can add to a template, you know, by hand, if you're not using the components that we built. But it also gives you a little background as to how we've built each of these components. And so once you drag things in, you should be able to go in and either double click on the line and learn about it, or double click on the point and learn about it, and so on and so forth. So that covers, let's see, a couple of things here in our slides. That is basically modifying your typical to the dimensions. Now let's talk about adding median conditions as necessary, and I've already added the typical end conditions out there. And I want to talk about some special end conditions like ditches and things like that here in a second. So go back into the SS3 template library and focus in on the medians. Take a look at the time. I don't think I'm going to get to everything today, but hopefully I'll get some of this. Now, our medians, if you will, in our static templates are just that. And if you look at the, if I just drag this down, notice that I've got a traffic separator, and then there's also a crossover in here as well, like in a situation down here, and then also at another intersection above there. And so in the past, we've delivered some pretty sophisticated variable medians. As a matter of fact, for a while there, actually in the last few years, part of our training manual was to build variable medians, and we've gotten a lot better at delivering them and also at making it simple for building them, and which is what I wanted to do next. In the template library, there's a separate folder. Once you've done a couple of these and kind of can understand it, you can go to this examples folder for training, and we have some of the ones that we had delivered previously over here. If you look in the examples for training and go to the typical sections, variable medians, you're going to see the standard PPM templates with at least three, the crossover, the curve median, and the traffic separator, one traffic separator built into it. And so each of these are built that way. So if you want to start from these, as long as you know how they work, then you could start with those. Otherwise, you're probably going to want to start with a static one and add to it what you need. So that's what I wanted to do next. I'm going to go through this probably faster than you would want me to, but just for the sake of time, at least it'll be recorded and you can go back. And before I do that, I've got to version this template since I've now added my end conditions in here. So I'm going to click on this template and copy it and paste it, and then rename it. And I'll call this the underbar 3 template. And then double click on underbar 3. And the very first thing I'm going to do is widen this median out, and I can kind of see that it goes from 11 to -11, and then I'm going to delete out the static median and just leave in here the point where this is going to be my PGL point on both sides, and I'm going to delete out this static median. When I say static median, for those of you who don't know, it won't, you can't just move or widen this pavement in here without it basically pulling the whole side. And it essentially doesn't follow a PGL at that point. So if I did like a test, and I did a test all, notice that this whole roadway side changes. And what I'm really wanting to do is add an additional lane width in the median for a left turn or for a traffic separator. I also don't have a crossover situation in here, so when I get to an intersection, it's going to try to draw a curve right through the middle of it, and that's not, obviously that's not anything that you want to model. So the first thing I'll do is delete out this static median, and I can do that by just essentially drawing through here like this, and I end up with just about everything except for this line, which was hidden. Wasn't necessarily hidden, but it was not displayed. And then I can just delete component on that, and I can delete out these extra points here. And what I'm left with, if I display the point names, is where my PGL points would be. And if you want to, you can rename this so that this is a hard PGL point. So you could call this the right pavement PGL. I'm sorry, left pavement PGL. And then on this side, you could call this the same thing over here. And then this typically doesn't have a horizontal feature constraint either, because that's going to be a hard distance that's either going to vary from the center line with a controlling alignment, or it's going to be a standard width, and then everything is sloped at the same slope inwards and up on both sides, and so you would essentially try to hold that point. Now our templates are also delivered with, let me get rid of this little baseline point, we're delivered with these 3 points here. One is the center line, and it's always 5 feet above where your PGL normally would be. And that's just so we can grab it and move it. And then also at the same 5 feet above your template are these what we call handles. And so the way we build these is we essentially will constrain the handles to the center line, and then we'll constrain the pavement to the handle, so that you can, if you wanted to just test, you know, the whole pavement, you could just sort of slide this back and forth and see how it works. It's also good for if you just needed to, if your median width changed from -11 to -15, you could just do an apply there, and it would change the median width in your template. But it would also be used for if you wanted to apply a horizontal, just a horizontal varying independent horizontal PGL line from your center line. Then you could just apply it to this PGL handle, and you could trust that this whole roadway would follow that handle. You could also apply it to this point, but what we're gonna find is that we're going to add a lot of things to this point. So having this handle out here that controls both roadways is useful. Just get used to using those. And then the next thing we're going to do is go into our median conditions, which I brought over from the template library. And we're going to add in a curb median. So I'm going to double click on this first and show you how these are built. So when you bring them over from our template library, we have a few standard median conditions out there. We have a traffic separator median, and it just has in the folder itself, it's just the type 1 option 1. If you want to use a different type of traffic separator, they're all individually out here the same way as it is. As a matter of fact, there is a copy of this type 1 option 1 in here, and they're all individual component sets. So just like I'm going to grab one of them and put it in here, you do the same thing if you wanted to use a different traffic separator. So I'm going to make sure this is my active one, and I've got a crossover median to begin with. Now, whenever you grab these, what you want to do is these have been built so that they marry up on the center line. So if there's a green point in one of these component sets, it's going to be 5 feet above where the PGL line was supposed to be. So as long as you grab from the green point, they will merge into your static templates. Otherwise, as long as your median width is the same median width. So what I'm saying is, if I just grab this now and drag it over here, as soon as I drop it on the center line point, the points name merge, and now I have a crossover median in my new template here. Now I'm going to do the same thing with the type E, and I'm going to drag from here, but I don't want to drag it right on here. The reason, I mean, you could, and as I add the logic to it, it would work fine. But what we're finding is we're going to try to put these up above so that you can see the different sets. So I'm just going to place it here for now, and then I'm going to right click on this point, and I'm going to say add a constraint full. So I want to basically constrain this to my other center line. Then I'm going to set it to be 0 horizontally, so it's right lined up with the other template. And then vertically, we just use 10 foot. I'm just using a 10-foot constant vertical offset. And what that will do, and if I turn off these point names, is basically it kind of creates what we call a floating median. And then the other thing I need to do is I need to constrain this point to the actual point that it's going to be tied to on the ground. I have 2 different types of constraints that I want to put on here. I want to constrain it to my PGL horizontally, and I want to constrain it to the PGL point on the template vertically. So how do you do that? Well, you can right click and delete, go to edit point here, or delete both constraints is what I usually do, and do the same thing over here. Delete both constraints there. And then you can just, if you want to just open up the point properties dialog and watch it go this way, you can select a horizontal constraint, and you can pick the PGL point or the PGL handle there and choose 0 and choose apply, and that'll put 1 constraint on it. And then the vertical constraint, you want it to be from wherever your PGL point is. And typically that would be 0, right? But in this case, we're going to leave it at 10 just because of the way we're building it. Now here is the trick to how to make these all fall into place. You just put in a label here, and I don't believe I have it created yet. You just create a label called V underbar offset. All right? And by doing that, then you can, when you place it in your corridor, this is a label that is handled with what's called a parametric constraint for a range. And all you do is you just go into the corridor's parametric constraint table and you add a vertical offset of 0, and it will move anything that has that label from where it is in its template down to its normal location. So in essence, it's doing the same thing as if you drag and drop multiple median conditions at the same location. It's just for display purposes and for editing purposes, it's a little bit easier to see and edit. And then just choose apply there, and I would go over to this other point, and I would pick the horizontal and set it to the PGL handle. So I see the PGL handle here, 0 offset, choose apply, and then select a vertical and pick the PGL point on this side, and then set the same label, which is now in my list, and choose apply. And then the only other thing that I have to do is tell this crossover that it's not to display whenever this search line or this end condition is found. So let's look at how this whole thing works. This line is the end condition that's looking for a feature target. In this case, it's looking for a curb and gutter type E, which would be the face line of what you draw in the 2D view. If that solves, and notice that it only goes between the two PGL points, if it finds a curb type in the median, then it's going to essentially, all of these are a child of this normal, of this search line here. And you can verify that by going over to the active template tab, and you'll see that now I have, for this search curb type E component, I have all of the components that are make up it underneath it. And that's how I know that there's a parent-child relationship. And so what happens if you test, remember I said I can test all my targets, so now I've added a target of feature type E, and if I draw that in the median somewhere, then it will turn on. And then when I actually apply it to my corridor, I'm going to set my vertical offset to 0, and it actually is going to draw in the median in its place. Now, what happens here is that I've got both the crossover and the curve median drawing, so I've just got to go add a simple rule to my template. So far, all I've done is I've basically added each of the different end conditions in here, and basically tied them to the PGL points. One of them merged them by dragging. The other one I actually had to set the constraints to them. And I also wanted to make sure that I set my, I set the, oops, sorry about that. I set the horizontal constraint to the PGL handle, so that if I were to test this horizontal control on my handle, you'll see that if the median moves in, the whole thing moves in. And then I could also test this point property on its own, and I could say, what if I have some type of horizontal override on this point? Then it will stretch and it will build the median. Turn off that. You'll see that it's building the median accordingly. And I have it set to active template, but if you wanted to see what it would actually draw like, you can do a test point controls horizontal. And notice that the median goes from a crown to a flat. That's because there's actually two components out here. There's this component, which is this flat line, and there's a crown component. And there's a display rule in here built in that says if this point gets beyond this point, then it's going to draw flat. And the same thing if the other point moves beyond the crown point, then it draws the flat. Notice that the crown is still solving, but it's only displaying the one that based on the rules. So that's the next thing. We're going to add a simple rule. we're going to go to this pavement component, and I know that all three of these, there's actually 4 components that make up the crossover median, right? There's the pavement and the base on the left and the right side. But what we do is usually make the right pavement the master over the left side, and then we make the base, or I should say the parent, not necessarily master, that's not a good term, the parent over the left side, and then the base, basically the base is the child of the parent, which is the component above it. All right, so if I apply a rule to this component, it gets applied to all 3 of them as well. And the rule that I'm going to build here, and you add rules in the pavement or in the component properties dialog. So I'll choose edit, and then I'll look at what rules I have out here. Well, whenever I brought in that curve median with widening, it brought in a rule here, which was that search line was solved. So if that search line is solved, and that's essentially what this rule is saying, component is displayed, what we want to do is turn off the crossover median because we don't want them both showing. So all you have to do is, what I'm doing is adding a rule to this component that says if this line draws, then this should not be solved, or it should not be displayed. And all you have to do is just apply the logic, not when this is drawn, selected rule, and that should equal false, and that's as simple as it is for adding a rule. And now notice that the crossover median now is dashed out. And if you test it, you'll see that because there's no curve median, the crossover is solved. As soon as I add a target and solve the target for the curve median, then the crossover turns off. It's that simple. At least it's that simple to me. All right, so now if you add in we're going to add the next one, which is a traffic separator. And I'll do the same thing. I'll just, I don't want to, notice that when I drag it, notice how I'm not dragging about the green point. I'm some arbitrary point out here. If I just let go of it and do a Control Z, now, whenever you want to drag from a specific point, you go to the preview window and you click on the point that you want to drag from, and it changes the drag box to whatever that point is. And if you got 2 of them real close to there, good luck, because you can't zoom into this preview window. You're going to have to just hopefully get on it. And I'm going to drag it over to the center line, and I could put it over here if I wanted to, except I don't want to have this affixes checked on when I do that. And my other one is probably messed up because I did actually do that way. So now when I drag it over here, these already have the affixes checked on. And in order to line this up with my median, I'm going to do the same thing. I have my center line point that holds everything in the middle. So I'm going to right click and do a add constraint, full constraint, pick this center point, and then set the value to 0 and to 20 in this case, because my first one was 10, my second one's going to be 20. As soon as I choose OK, it moves it over here. Notice that this one is a little wider, so I'm going to right click. I'm going to do this a little faster, delete both constraints on both these sides, and then I'm going to add a horizontal constraint to my PGL handle, this point here, set it to 0, choose OK, add a horizontal constraint to this PGL handle, set it to 0, choose OK. Then I'm going to add a vertical constraint to this point on my pavement here at 20 feet, add a vertical constraint to this point on this side, 20 feet, should be 20 feet, choose OK. Then I'm going to make sure that this label is set to V offset, because that's actually got to be placed down on the pavement in the corridor. Same thing over here. Choose apply. Then the last thing I have to do is make sure that this pavement doesn't draw if it also sees this traffic separator search line. So I'm just going to put in here and not when you see a traffic separator, and that's all there is to it. So then if I go to the test, you'll see it's a crossover unless there's a curb, and then if there's a traffic separator, it'll turn off the crossover median, and now I've got a traffic separator. And then because I have the vertical offset set in there, it will put them in the correct location in the template. And if you wanted to add in a shoulder one, it's the same steps. Now I can tell that I'm going to run out of time, so I'm going to have to we're either going to have another template webinar, or I'll have to record one on the side. But let's see if I can get back to my PowerPoint presentation here. I've got to close out of here first. All right, wrong one. Hold on a second. Here we go. So that was adding median conditions as necessary. I also talked about adding typical end conditions. Special end conditions would be things where, for example, you wanted to add a ditch line or multiple ditch lines or things like that. And then the same thing with adding, basically having certain components turn off whenever there's an intersection. What to do with the crossover. I've already kind of talked about that as far as how it turns on and off for different things. One of the other things I would do is check to make sure that all my point properties have the right feature type, and also looking for the right horizontal feature constraints. And then would want to test those. And then you've also seen me test the point controls by using the test button. The other thing that you would need to do on your templates is make sure you're checking for super elevation and vector offsets. What is that? If you go to the, again, if I can bring up the template library. Turn off that and go to quarter modeling, create template. Any of the points that you want to apply super elevation to, like for example this outside point, there's now a super elevation flag that needs to be checked. That's one thing. This is where you would actually check your horizontal feature constraint to make sure that it overrides if you're adding like an additional right turn lane, and then you give it a range. I wanted to have more time to sort of talk about that, but I'm running out of time. The other thing about vector offsets, and this is going to be hard to explain, but essentially if you want a turn lane to follow the same super elevated slope as your pavement, you don't necessarily have to add a super elevation section to this lane. You can use what's called a vector offset on the constraint of this slope. For example, this slope right now is supposed to move in at a 2% according to wherever that left turn bay lane would be. If you want this to follow the same super elevation as this pavement, then what you would do is put in a different type of constraint. The constraint would be called a vector offset. And you would basically pick between this point and this point as the vector that you want to this slope of this pavement to follow. The trick here again is that you just, where right now that vector is 9.998 feet above where this slope would be, you can just leave it at that offset and then go in and pick the vertical offset and apply that to the vector offset, so that when it drops down into place it's zeroed out as well, and then you'll get this this pavement to follow the same slope in a super elevated section as that. So that's what the PowerPoint meant by making sure that you check for super elevation and the vector offsets. The other one here is the do not triangulate points. And if I can get back to, do not triangulate points would be these points right here. Like anytime you have a miscellaneous, like in this case, this is a miscellaneous line that we're adding to the template. You want to make sure that these points here have this, and it's actually not the points, it's the component itself, which is exclude from the top and bottom mesh. It used to be called exclude from triangulation. It's now set to this exclude from top and bottom mesh. And by checking that, you won't have that extra line trying to build as part of your surface, because that's really just a location line. It's not necessarily for that. Now let me just kind of go through the rest of these questions here, or typical questions, and then I'll wrap up this webinar. So one of the questions I get a lot is my cross sections don't look right according to the way my template was built, and usually 9 times out of 10 it's because there's some type of a range override or a horizontal feature, what we used to call style constraint override, on one of your point definitions, and the range that you're looking for it's just out of whack, if you will. And you know, it's an edge of pavement line that's looking for a pavement proposed line. Either you didn't add it to the corridor in this case, or it's not within the range that it's looking for. A lot of times that's what it is, and it's going to make your cross sections look like totally contorted. And usually it's one simple little thing. It's one little check or one little box. So don't panic when you go to look at your cross sections and you've got twisted pavements out there or curbs that are 40 feet wide or something like that. It's typically because you have something checked that shouldn't be checked, or you have a range that's outside of the normal location of that line, the override of that line. Another question we get is, how do we add a 3% slope on the outside of my pavement for the widening? Well, there's a couple ways you can do that. You can't just add a component with a different slope to a component. You have to have, just like when I collapsed the utility strip way at the beginning of this webinar, you can actually have a pavement section that's collapsed down to 0 and has a vertical or has a slope constraint on it of 3%, and have that actually target the edge of pavement line as well, so that when it finds one, extends it outside of the normal width of your roadway, it will actually be at a 3% slope. That's one way of doing it. You could also just have a whole nother set that you trigger on whenever you see a right turn lane. There are other ways of modeling that same thing. How do you match existing or cross slope correction on resurfacing? That is as simple as editing that outside slope line, like for example in the corridor templates for the resurfacing. If you want to match existing between 2 points on your existing surface, then what you do is, for your overlay component, you set the outside point to project a surface. If you want it to correct the slope, then you set the slope that you want it to be corrected to, and you have to make sure that it has a parent point, and then you would set like a minus 0.02 or a 2% slope, and what will happen is it will build this overlay in at the slope that it's set to, and then the overbuild and the milling will adjust according to what this overlay needs to be. The overlay thickness is still going to be the same. If it has to put in overbuild, it will. If it has to mill down farther, or if it gets milled down farther than a normal slope, then it will, and it actually creates your variable depth milling that way with a cross slope correction. There's lots of other ways to doing this, but that's the simplest way. If you want to match existing between 2 points on your surface, you set this to project the surface and project it to the active surface, and that will do the match existing. Otherwise, you leave it at a slope constraint and it does the cross slope correction. Another question, let's see here. How do you add driveways? How do you add curb ramps? How do you model your traffic separator noses or your curb noses? How do you add model or basically add restricted left turn islands? All of these are going to be handled a lot differently in SS3 than trying to create a template for them in like we used to in SS2. In other words, if you have any of these questions, you're just going to have to wait until we do the detailed modeling, and I'll show you how we've got civil cells for a lot of these things. These are what I call, well, a traffic separated nose really isn't an appendage, but these are sort of appendages to your corridor. You're going to let your template do, you know, just a broad swipe through your corridor. And then when you get into these detailed sections for like intersections and driveways and turnouts and all these extra things that are hard to make templates to do, or even a restricted left turn lane, then you're going to go to the detailed modeling tools within SS3 to build those. Any kind of an island, you're just going to sort of build a crossover pavement and drop the island on top of it, and then try to control your slopes to the edges of those pavements with your modeling tools. Another question is, what if I want to change the PGL location on my typical, or not necessarily on the typical, or from typical? So I've seen projects where they actually put the PGL, or the line that they're trying to hold, is on the existing ground, on the existing outside edge of a pavement. They want to mill everything from the outside inwards. Well, it's just a matter of reconstraining the points on your template, okay? And you know, I don't have a whole lot of time to demonstrate that, but you can apply that just as easily as a standard PGL location. Can I hold a point, or how do I hold a point on the right-of-way line? Like, for example, I want to maximize a lateral ditch, and I want to use as much right-of-way as we're buying out there. So I want to basically start at the right-of-way line, come in the 2-foot maintenance sod slope, and then I want to slope down to a depth, and then I want it to go over to the corridor and go up at the standard slope till I get to my clear zone point. That's really easy also to build into our templates. You just basically constrain your outside point to the right-of-way line at an offset, and then that is going to set one side of your ditch slope, and then you basically constrain the other side of your ditch slope from your shoulder point or from your clear zone point, and you just let that line in between those vary according to those two controls. It's really simple to do. If you need help with that, maybe I can actually show it in one of the future webinars. Thank you for attending.